So I'm Gillian Armstrong, and I'm a technical lead on the Cognitive Technologies team in Liberty IT. Liberty IT is based in Belfast and in Dublin, Ireland, and we build software for Liberty Mutual Insurance in the US and across the world. I've also recently started working with WorkGrid Software, which is a startup launched by Liberty Mutual. Now, before I start, how many of you here have built a chatbot? I know some of you did yesterday. Oh, quite a lot of people. That's good. I'm going to go very fast today. I'm going to skip through lots of things. I'm going to skip past lots of things. So if you want to know more, come and talk to me afterwards, or that's my Twitter handle. So before I start, quick disclaimer, it is perfectly possible to build a brilliant chatbot without using any artificial intelligence. I'm not going to talk about those today. I'm going to specifically refer to Amazon Alexa and Lex. There's lots of other cloud platforms. I don't judge anyone's technology choices. The reason I'm going to cover those two is because we built our chatbot with Lex, but a lot of people are more familiar with Alexa, so it's nice to do some comparisons there. If somehow you aren't familiar with Alexa, you've never heard of it, it is Amazon's own digital assistant. It lets you extend and add custom functionality to its already quite broad functionality by building something called a skill. Amazon Lex, on the other hand, is an AWS service, and it lets you build your own conversational interface anywhere you want using the same conversational engine that is in Amazon Alexa. Now, it's standalone, and that is a really important word, because when you build with Alexa, your users have access to all the functionality that Alexa has. When you build with Lex, your users only have access to the functionality that you have built, which means that you get users asking your chatbot for jokes or the weather, something it's not built for, because they're used to Alexa and they're used to having a wide variety of functionality. And why that's important we'll get into later. So why build a chatbot at all? Well, definitely don't build one just because it's the new cool thing or everyone else has one. There are lots of use cases that are terrible for chatbots, but there are lots that are. It's a good way to collect simple information, to get simple tasks done, to answer simple questions. You can replace your FAQ on your website. It's happy to chat to one person at a time or 1,000 people at a time, and it doesn't sleep. It can be there for your users 24/7. And I think most critically, because voice is the future user interface, we should expect to see adoption of conversational interfaces have the same adoption curve of mobile. As developers, we all need to learn to build for this new interface in the same way we know how to build for web or mobile. So why did we build a chatbot? Well, in Liberty, over the last few years, we have been investing in employee experience. So obviously, the ultimate aim is to improve the productivity of our 50,000 employees. But we also want to give our employees a more engaging and consumer-like experience interacting with internal systems, which are generally not very pleasant to interact with. The chatbot is just the latest evolution in that. And here it is. So it's sitting on our intranet as part of our larger productivity suite. And you can talk to it in natural language. So just like having a friendly coworker that sits beside you and knows all the answers to everything. It deals with lots of central IT functions. So you'll see here it looking up person details, but it can look up HR policy details. You can get help desk questions. It can help you if you've locked yourself out of your work phone. You'll also notice that it is personalized and contextualized to you. So here I'm asking about lunch, and it's telling me the details for the Belfast office where it knows that I'm based. However, you'll see when I ask about the Boston office, it gives a different answer. Now, the lunch menu might seem like a really silly example, but it's actually one of the top search terms on our intranet, and it's functionality that is used in the chatbot every single day. So it just goes to show that you don't necessarily need something very complex to have something that's useful for your users. Now that chatbot you've just seen is internal, But it's been such a success in-house that, as I've mentioned, we have spun off a startup called WorkGrid to make the same functionality that's helping our employees in-house available for other companies to benefit from. It's still in preview, but we're pretty excited about what's to come. So for those of you who haven't built a chatbot, we're going to take a very quick step back and talk about some of the terminology. So the first one is utterance, and that's just what the user said. And next we jump into a whole pile of that conversational AI. This is where the magic happens. So you've got natural language processing. So right away you get your automatic speech recognition, that's voice to text. You get named entity recognition, that's pulling out things like names and dates and times. And natural language understanding, which is matching what the user said to what the user meant. So for instance, if I said, book me a meeting at 3 p.m., I would expect it to be able to pull out the time of 3 p.m. and then know that when I said book a meeting, it should put something in my calendar. Now, if you know what it means, but you don't do anything, it's not very useful. So this is where the final piece, fulfillment, comes into play. So this is the bit where you're going to have to write some code and take some actions, and then, of course, respond back to the user and let them know that you've done that. So what does that look like when you actually build a chatbot? I'm going to take a quick look at the Lex console. The Alexa console is slightly different, but it's very similar. If you're familiar with one, it's easy to jump between them. So the first thing here is the intent. Now, a moment ago, I said that that's where the magic happened. Unfortunately, it's not quite true. As much as I wish they were, chatbots aren't magic. And this chat will only be able to understand the intents that I have defined here. So this one doesn't do too much. It books that meeting. It can say hello and goodbye. It won't be able to understand anything else. Next up, the absolutely critical core piece to this. These are sample utterances. So as I said, utterances are what the user said. So these give examples of the types of things a user might say if they wanted to match that particular intent. Now, these are not a list of things for it to match against. It's not looking for exact matches. These are training data. So when you build your interaction model, that natural language understanding underneath will generalize on them, and it will be able to recognize things that are close to what you've written. This is core. If you don't get this right, you will not have a good chatbot. So if we scroll down the screen, you'll see the slots. So here we've got date and time and person. And hopefully you noticed up above that they were also included in the sample utterances, which helps Lex recognize where in a sentence it should be looking for them. Again, there's no magic here. It was only going to try and recognize the slots that you have defined here for it. These ones are using built-in Amazon slots, but you can define your own custom slots and put anything you want into them. Now, if it recognizes that the user hasn't given that information and is required, Lex can automatically prompt and gather that information for you. And almost the final piece, fulfillment. So you'll notice how easy it is to hook straight up to a Lambda. Very easy, just you pick it from the drop-down. You don't have to. You can use an API instead. And very critically, you've got a nice test console, so you don't have to hook it up to any client to test it. And up the top, there's build and publish. Now, when you click build, that is when it builds your interaction model, uses all that training data, and actually creates your bot. Publish will release that live to your users right away. If you're building an Alexa skill, you're going to have to wait for it to go through certification. So let's very quickly look at a couple of the flows through Alexa skill and Amazon Lex, just to compare them. So the first thing you'll notice is that for an Alexa skill, the interface is Alexa itself. So anywhere Alexa exists, your Alexa skill could be accessed through it. Whereas with Lex, it's just an AWS service. So you're going to have to define the interface for it. It has a number of built-in connectors, but you can create a custom interface like we did. Now, Alexa is going to handle some things like user IDs and information about the device itself. You may have to handle that yourself if you build a custom interface. You'll also notice Amazon Polly here, and I haven't mentioned it yet. That is another AWS service, and it does text-to-speech. And if you haven't played with it, it's great fun. You can use it on its own, but Lex uses it in behind the scenes. And that's important because while Alexa is basically free, Lex and Polly are not. So there is a free tier, but after that you will get charged. You notice they're hooked up to Lambda functions. You can go straight to an API, but there's lots of advantages with going to a Lambda in that it handles a lot of the security for you. Now, if all you hook it up to is a Lambda, it's not going to be the most interesting chatbot in the world. So you're probably going to want to hook it up to an API or some other external service so it can actually take some sort of action. But of course, even in this simplest scenario, it's never quite that simple. Because of course, you have logs. Hopefully you have logs. You're probably going to want to save some data. Maybe you're going to want to run some reports. Perhaps you're going to want to do some background processing. All of that's going to need more lambdas, and so on and so on. So it suddenly becomes a little bit more complex. So what does that look like for the chatbot that we've built? Well, here is our conceptual serverless architecture. So it's not an architectural diagram because that doesn't fit on a slide very well. But it shows you all the different pieces. So let's walk through it. So right away, you're going to see our user chatting away in the middle. And you'll notice that she's not going directly to Lex, although we can hook it up directly to Lex. We're coming in through Amazon API Gateway. And as we do that, we are injecting our own session and our own context using Lambdas and DynamoDB. Now, in that session, obviously, we have information about your user, about the device, but we can also pull your employee information, so who you are, what's your title, what office are you in, who's your manager. And we also pull your conversation history. So what have you just been chatting about? Because while serverless is stateless, conversation is not. If I forgot everything you just said a moment ago, as we talked, you wouldn't find it a very useful conversation. So we pass all that session and context on to Lex to translate what the user said to an intent. Now, you'll notice that while Lex is a really important part of our architecture, it is just a tiny part of this diagram. Amazon Lex, of course, maps to fulfillment lambdas. And we have a number of different fulfillment lambdas. So we have ones that hook up to internal services on-prem, and that's why you see VPC and Direct Connect up here. We have ones that integrate with other AWS services, and ones that call out to third-party APIs. And we have others that are simply hard-coded responses. And this is where the context comes into play. Because that context, knowing who you are, knowing where you are, allows us to take very personalized action and responses for you. And finally, and really importantly, we have analytics, monitoring, and reporting. So you'll probably have noticed that while from the outside, it just looked like a simple chatbot, that what we've actually got here is a highly distributed architecture. So to see what's going on, we actually take all of our CloudWatch logs, and using log group subscription filters, we stream all of those logs to Elasticsearch. So we've got one centralized view of all our logs. We also have CloudWatch dashboards for all of our key services, and we use CloudWatch alarms to let us know if anything is going on that we should be aware of, if there's throttling or latency. So we want to know right away if there's any technical problems with our chatbot so that we can jump in there and get them fixed. However, equally critically, we also stream all our conversation. And all that conversation stream is used to create chat stream analytics. We've got a couple conversation boards up in Cabana that give us a real-time live view into what's happening with our chatbot right now. How many users are on? What are they asking? How well is our chatbot performing? Is it actually understanding what the users are asking? And of course, we also dump all that conversation into S3. And we've got Athena on top of that, so we can run reports and feed all of that back into continuously improving our chatbot as well. So, a moment ago, I showed you the console and how easy it was to create the chatbot. Jump in there, type some stuff in there, perfect, done. And while it's really easy to create it, it is not so easy to keep track of it. So if I've gone in and made some changes, and Vincent's gone in and he's updated some of the utterances, and Christine's gone in and she's added a whole new intent, trying to come in and visually see what's happening is very difficult. So I would highly, highly recommend that you don't create your chatbot through the console. It's okay to go in and start that way, but I would recommend that you create it through code. And that lets you have that traceability. It lets you be able to do really great testing. And it makes everything very repeatable. Now, I'm not going to have time to walk through our CI/CD pipeline today, but I do want to point out that everything in that diagram you saw before, including the chatbot, is all created through code. Everything is observable, everything is traceable, everything is testable. We create it all through code using CloudFormation and filling in the gaps with custom resources, so Lambda-backed custom resources, including the one that we use to build our bot using the Amazon Lex model building service. And all of that lets us be able to take that same stack and that same bot and deploy it into any AWS account and know that it's exactly the same. So we have a different account for testing and for our live system. So why serverless? Well, obviously the obvious one that's been mentioned already today is that if nobody's talking to your bot, it doesn't cost you anything, potentially. Conversation is an event-driven thing, so it is triggered by a speech event. But if everybody comes in and wants to talk to your chatbot, it scales. Obviously, ours is an employee chatbot, so we get lots of employees coming in and chatting to it first thing in the morning, at lunchtime, get those lunch menus, but almost no one overnight or at the weekends. We seem to have one or two who chat to it at 4 a.m. I don't know why. And of course, Lambdas are really quick to develop. We actually have a different one for every fulfillment. So that lets us slot in different conversations really easily. They're isolated from all the others. And in Lex, you can have a different Lambda for each intent, so you can actually scale different parts of the conversation independently. And the cloud is giving us an agility in our software architecture that we just never had before. So we can take all those services, we can build them up, we can change them around, we can remove them when Amazon announces a brand new thing that means that the last 3 weeks of work is now obsolete. Yeah, some people know what I'm talking about. And being able to change quickly is really vital for some of the reasons that I'm going to talk about in a moment. But a couple lessons learned, and again, some of these have been mentioned already today. Conversation needs to be fast. So while I said it was triggered by an event, it is then synchronous. Your user's not going to wait for you to get back to them at some point in the future. So you need to know your SLAs for your APIs. How quickly are they going to come back? You also need to really consider if you're chaining things. So if you've got a Lambda that invokes Lex, and Lex invokes another Lambda, and maybe it invokes another Lambda, those cold starts, that spin-up time, can really start to matter. It's not wrong to do this. You'll have seen a number of Lambdas on our architectural diagram. But X-Ray has really helped us here. It's allowed us to spot where the problems are, to keep some of our Lambdas warm, or even to take the functionality out of them, put it into a library, and include it in another Lambda. And make sure that everything in your architecture scales. On our first game day, we very quickly discovered we'd forgotten to turn auto-scaling on our DynamoDB, which caused us a few problems, thankfully easily fixed. And beware of the cost of scaling other parts of your architecture. And monitor, at a minimum, you should know if your chatbot is up or down. So a few tips, I could talk about this for hours. I'm not going to, nobody panic. The first one is that bot interaction model. Getting it right is really hard. It's going to take a lot of iterations. Users are going to come in and ask unexpected things. They're going to come into your book a meeting bot, and they're going to say, create me an appointment, and you haven't used that word anywhere in your utterances. Or they're going to say completely unexpected things like, tell me a joke. So this is going to take a bit of work to get it right. And if I can give a quick example of why that is, here's the reason why it's so hard. So this is you. And you're sitting in this room right now, and you know that you're a human. You know that there are other humans around you. You know that you need air to breathe, that this room is inside a larger building that's in a city. Outside that city, there's a whole world. That there's dogs and cats and birds out there. The birds can fly. Dogs cannot. You understand abstract concepts like time and love and home. And you understand that when we talk about the cloud today, it's different than the clouds that are outside there in the sky. Here's your bot. While you have taken all those things, when you hear a sentence and you understand it, and you have brought all those things you know to understanding that sentence, this is all your bot has when it hears a sentence and tries to understand it. Your interaction model. That is its entire world. It doesn't know anything else. And every time you take that model and you change it, even if you just slightly reword one of the utterances, when you rebuild it, it wipes away everything it knew before, and it now bases its new understanding off that new interaction model. So you don't have an updated bot, you have a brand new bot. So anything that worked before, all bets are off. It might not work now. We have a full set of regression tests. You are going to have to retest everything every time you make an update. And writing a good conversation script is really hard. It takes a lot of creative writing skills. You need to think through every flow. You need to make your error messages conversational. Only developers are going to appreciate your chatbots suddenly saying 404 not found. So what I recommend is that you sit down and you practice that conversation with someone else. One of you role play the bot and have your scripts, and the other be the user. Now, it's a really awkward thing to do at the start, but I guarantee you it will help you write a better conversation. And finally, get feedback. It is essential. Our chatbot allows users to give feedback directly through the chatbot, but we also consider everything that isn't matched a form of feedback as well. That tells us what the user expected it to do or what they wanted it to do. So we take that on board as well. And we also monitor everything all the time and iterate back in there. So that's another form of feedback as well. So work to be able to rapidly fix, put all those things in place. Get your automated tests, your builds, your deploys, have great logging and monitoring. And that means that when you make a change, you can get it out to your users really quickly. So take your baby bot, be a good teacher, and help your bot grow up.